Hi everybody. So we're going to do compounding continuously. Again, not a very creative title. So y is compounding continuously. A of t is equal to p e to the rt. Okay. So this is basically why the formula is the way it is. And compounding continuously means we would complete the process of compounding and immediately begin it again, and we just keep doing it over and over and over and over again for 24 hours a day for 365 days a year. There's no breaks, there's no stops, it's just going off to an infinite number of times of compounding. So what we have is where we're going to begin with the compounding formula, like when you're doing quarterly or you're doing monthly, that kind of thing. So we have p 1 plus r over n to the nt. Now there's two things we've got to catch here. So the first thing is we're going to multiply by 1 in this exponent by r over r. It may not be obvious yet, but I'll try and explain it as we go. And we also need to recognize that r over n is the same thing as 1 divided by n over r. And to convince you of that, so 1 divided by n over r, it's a copy dot flip, so 1 times r over n, well that's r over n. So you can write it 1 over n over r, or you can write it r over n. But for this application, we need it in this format. So here is 1 over n over r. And the reason that we have that, or we're trying to get to that, is we're trying to get to the formula for the number e. And if I can, e is approximated by 1 plus 1 over some value raised to the value. And what you have to have happen is that value x, which is here and here, needs to go off to infinity. Okay? So this r over r is going to get split up. It's going to get moved underneath the n, the denominator is, and then the r in the numerator is going to just hang out with the t, and eventually it will become rt. And what I want you to notice is this is now 1 plus 1 over some number, and we have the same number in the exponent. Okay? So now it's 1 plus 1 over that value raised to that exact same value. Now we need to think about this for a second. And I replaced n over r with the letter L. Okay? I don't know why I chose L, I just did choose L. So remember, r is a fixed value, it's the interest rate. But the number of times that you're compounding is heading off to infinity. It's getting massive. So you have a massive number divided by 0.05. So if I take 1,000,000 divided by 0.05, it gets significantly larger than 1,000,000. So what's happening is, as n is going off to infinity, L is going off to infinity. So this is getting massive. This is getting massive. And so in here, this expression, it becomes the number e. And our exponent on the number e is the rt. Now you can commute that. That's how it becomes the rt. And now we have principal times e raised to the rt. And the e is actually a button on your calculator on the 84. I believe it's down the left-hand side, and it's on the ln key. And you'd have to hit the second button to get the ln. So just real quick, for an example, you have $50 and you want to compound it continuously at 5% interest for it's supposed to be 50 years. I put 5 years, but it's supposed to be 50. So the 50 is your principal. That starts here. You find your e. It's the button on the calculator. And then you will put in 0.05 times 50 because it's in there for 50 years. Okay? All right, hopefully that's helpful.